Alright guys, so we're going to get into complex numbers here. So basically the idea of complex numbers, it allows you to have square roots of negative numbers is one thing it lets you do. Because those are not real numbers, right? You can't take the square root of negative 25 or something, right? There's no number times itself that's ever going to equal a negative. There's no real number, I should say. So let's take a look at how that works and kind of tie it into our quadratic equations unit that we're doing here. So as a quick little intro, if we think about, we talked about how the graph and how the equations kind of relate to each other. So if we think about the graph of y equals 2x squared plus 4, you could throw that into a calculator or plot some points, but you would kind of see quickly that it goes, it would start out at 4, and then let's see, we kind of do something like this, and be that parabola shape. Just remembering, like from before, the plus 4 would kind of vertically shift up 4 units, and we'll get into more of that down the road. But the idea is to solve the equation 2x squared plus 4 equals 0. If you recall, we looked for the x-intercepts, right, or the zeros or the roots. So this graph doesn't have any, right? It never really goes through the x-axis. It never has a point where the y-coordinate is 0. So when we try and solve this thing, let's say we try to factor it, right, because that's the method we've been using. We could factor a 2 out, and then we would have x squared plus 2 equals 0. So then when we set the factors equal to 0, using the zero product property, x squared plus 2 equals 0, x squared equals negative 2, and that's kind of what we were just talking about, right? There's no real way to get a number times itself to equal a negative number, okay? So let's kind of come back to that, but make the connection right now that the graph shows no x-intercepts and that the equation then has no real solutions. Okay, so one big thing in this section that we want to do before we do any more with the complex and imaginary numbers is just kind of a review of simplifying radicals, and then we'll get into the negative ones as well. But basically what you want to do for the square root of 45, and you may have done this, back in geometry with the Pythagorean theorem or something, is a good place where this comes up. But the idea is we want to reduce any radicals, any square roots, and get them in simplest terms. So the trick here is to think about perfect squares, okay? So perfect squares are something that the square root is a whole number. So like 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, 16, 25, right? Because each of these have the square root as a whole number. So when you're breaking these down, you want to use one of those as your factor. So for example, with 45, there's probably a few ways to break down 45. But the smartest and quickest way is going to be to use a perfect square of 9 times 5. And the reason that's going to be the quickest for us is because we know the square root of 9 is really just 3. And then the square root of 5, there's really nothing you can do with the square root of 5, so we're just going to kind of leave that alone. So the square root of 45 could be broken down into 3 times the square root of 5. And it's kind of just like reducing a fraction. You're just getting smaller numbers. And you can always check these, make sure they're right using a calculator. Do the square root of 45, might be 6 point something. And then verify that 3 times the square root of 5 is going to be that same decimal. Okay, so let's try another one, 48 here. So if we want to break down the square root of 48, so there's a bunch of ways to get 48. You could do 6 times 8, you could do 24 times 2. But again, if you want to use one of those perfect squares, it's going to be a lot quicker if you recognize that it is 16 times 3, because 16 is a perfect square of 4, and then you have the square root of 3. Okay, let's just say you didn't recognize that though, and you did a little different way. Let's say you went with I don't know, 6 times 8 or something, right? 6 times 8. Okay, so it's going to take longer because we got to go through and get these all kind of as far down as we can. So for example, that square root of 8, I want to do the square root of 4 times the square root of 2. Okay, so far what we have, if we start collecting what we have, the square root of 4, that's the perfect square, that equals 2. And then the square root of 6 times the square root of 2 is really the square root of 12, because you can multiply them back together. But the issue is that 12 has a perfect square factor of 4, because 12 is 4 times 3. So now what we really have is we have that 2, Okay, here's another factor of 2, and then the square root of 3 we can't really do anything with. So we kind of end up at the same spot with the 4 root 3, but there's a lot more room for error and just little calculation and arithmetic mistakes. So if you can do this way first and get that biggest perfect square the first time, it's just going to save yourself some work. Okay, square roots with fractions. Okay, so it's tempting to just kind of throw that in a calculator and get some crazy decimal, but a lot of times you need an exact value, or there's a chance you see something on a no calculator test or something. The SAT has that no calculator portion. So to simplify fractions, you're really just thinking of it as the square root of 32 over the square root of 49. Okay, you can make it the square root of the top and the square root of the bottom. Now the 32, again, think about perfect square. Instead of doing 8 times 4 or something, let's do 16 times 2. Okay, and then on the denominator side, the square root of 49 is a perfect square. That's just 7. And then what we can do with the square root of 16 is a perfect square, right? So the square root of 16 is just 4. Square root of 2 is still there, and then a 7 in the bottom. So this is more exact than just getting some decimal from a calculator. And again, you may not always be able to use a calculator. So just think of it as 2 separate problems and simplify each individually. Okay, so now let's start talking about some of the newer concepts. If we have negative numbers in the mix, okay, either on the left there we see a negative on the outside, in the middle we see a negative underneath the square root, and then the far right actually has both. Okay, so basically what you want to think about, if the negative's on the outside, like this first one, it's just really saying, figure out what this reduces down to, and then we'll just slap a negative sign in front of the answer. Okay, so that negative sign is still on the outside. The square root of 18, we want to do that, instead of like 6 times 3, we really want to do 9 times 2, okay, because 9's a perfect square. Okay, so what we really have now is the opposite, or negative. The square root of 9, of course, is 3, and then the square root of 2, we're not going to do anything with. Okay, so this answer is actually negative 3 root 2. Now the middle one's a different story. Okay, that one's the square root of a negative number. This is the one that's not going to be a real answer. Okay, so the trick here, the idea is we want to do the same kind of thing. We want to bring out the negative 1 times 18. We know 18 we just did is root 9 times root 2. Okay, but here's the deal, okay? This is the new concept. The square root of negative 1, okay, this was kind of just defined or just made up to equal, let me write this down here. The square root of negative 1 is what we're going to refer to as I. So it stands for an imaginary unit, and it was basically designed or created to handle this type of situation, among others, when you have a square root under, or a negative under a square root, I should say. Okay, so we're going to get into more of that in a little bit. For now, we just need to know the square root of negative 1 equals I. Okay, it's not a real number. It doesn't equal negative 1. Okay, it equals I. So for our problem to finish here, if we just kind of gather up what we have the square root of 9, which is 3. Okay, the square root of negative 1 is what the new thing that we're calling I, and then we still have the square root of 2. Okay, so the final answer to this one, we're going to just read that as 3i root 2. And you generally put the 3 or the constant and the i's before you write a square root, just so we don't confuse and think that it's under the square root. If you wrote it like this or something, it might be a little bit unclear as if the i's under the square root. So generally, you're going to want to write that before you write the square root, but it's not wrong the other way. It's just kind of more a standard form. Okay, so anyways, the one on the far right here, we have the opposite, and then we have the square root of negative 18. So I'm thinking of it as the opposite of, and then doing this problem like we just did, the square root of negative 18 is what just happened over here. So it's just 3i root 2. Okay, we just happen to have a negative sign out front. So that negative sign just went there. And then the square root of negative 18 was the same problem we did in the middle. Okay, so let's try just a couple more of those with square roots of negatives. So I'm going to suggest always bringing the negative 1 out first and just leaving the rest, and then kind of treat the treat the 12 as a positive and break that down. So with 12, again, you don't want to do 2 times 6. You want to get a perfect square. You want to do 4 times 3. Okay, and then let's kind of just tally up what we have now. Square root of 4 is 2. The square root of negative 1 is this new concept called I. And then the square root of 3, nothing we can do. It's just the square root of 3. Okay, and then with the square root of negative 100, so again, it's negative 1 times 100. Okay, these are both actually things we know. The square root of 100 is 10. Right? That is a perfect square. There's no need to break it down and do steps. And then the square root of negative 1 is what we call I. Okay, so the square root of negative 100 is just 10I. So basically, just be prepared. Anytime you see that negative under there, you're going to get an I as part of your simplified format. Okay, so let's revisit our warm-up equation. So if you remember when we solved this, or we tried to solve it and we got stuck, we first factored a 2 out. We got 2 times x squared plus 2 equals 0. You could divide both sides by 2 here to get rid of that 2. The right side's still going to be 0. So basically, we're just going to be solving x squared plus 2 equals 0. And to solve that, we would, of course, subtract 2 from both sides. So we get this x squared equals negative 2 deal here. And we haven't done this yet this year, but we will. To undo squaring, right? We're probably familiar with square root. So what we're going to do is take the square root of both sides. Okay, so x is going to equal, and there's one more thing here. When you solve an equation taking square roots, and we're going to do more of this later, but when you do that, you need to include the positive and the negative. So we do a little plus or minus in there. And the reason why, let me just do a side example a real quick one. If you had something like x squared equals 9, right, and a lot of people would just say, all right, we'll take the square root of both sides and get x equals 3, right? And that's not wrong, okay? The only problem is that's not the only solution, okay? If you check x equals 3, right, when you square that, you do get 9, but if x were negative 3, right, wouldn't negative 3 squared also equal 9? So that's why when you solve by taking square roots, you include the plus and minus, because the negative 3 also solves that. Okay? And again, we'll do a lot more with that down the road, but just at this point, just kind of keep that in mind. Whenever you take a square root to solve an equation, you're going to do the plus and minus. Okay, so for our example, back to this one here, we have plus or minus. Now the square root of negative 2, again, it's going to be, we're going to take out the negative 1 and have the 2 there, right, since it was a negative under the square root. And then since we have the square root of negative 1, that's just what we learned today is I. So our answer is going to be plus or minus I root 2. Okay. So it's like saying positive I root 2 and negative I root 2. That's what the plus or minus means. It's both. Okay, and we just say an or, but it means we have to list both. But both of those are solutions to the equation. And since they're imaginary, since they have that I in there, that's again kind of showing why the graph, when we first started the warm-up, the graph didn't have any x-intercepts, right? Because they're not real numbers. Okay, so that's kind of what to expect on those. Assignment will be page 123, numbers 7 through 10.